Momentum. What is momentum? We hear this word used often in sports, but what does it really mean? Momentum can be described as the quantity of motion of a moving body. If an object has motion, then it has momentum. The amount of momentum that an object has is dependent upon two variables: how much stuff is moving and how fast the stuff is moving. These two variables are called mass and velocity. Momentum is the product of the mass and velocity. In our example, Nick and Spencer are skipping across the field. They have a mass and are in motion, therefore they have momentum. Nick and Spencer have a combined weight of 140 kilograms and travel at a velocity of about 1.2 meters per second. We use the formula P equals mv to find momentum. So 140 kilograms multiplied by 1.2 meters per second gives us their momentum, which is 168 kilogram meters per second.
Let's look at another concept, conservation of momentum. The law of conservation of momentum states that the total amount of momentum in a closed system of objects is constant, meaning no matter what happens in the system, its initial momentum will always equal its final momentum. In our example, the pool ball has a mass of 0.2 kg and has a velocity of about 0.3 meters per second, while the other pool ball has an identical mass and is at rest. If one ball stops dead after the collision, and the other ball will continue to move with the same momentum that the first ball started with. We can see this by using the formula m1v1 plus m2v2 equals m1v1 plus m2v2. After the collision of the first ball transfers its momentum into the second ball, and that second ball moves away with that momentum. Impulse. Impulse is change in momentum, which is directly proportional to the force applied. A small force applied for a long time can produce the same momentum change as a large force applied briefly, because it is the product of the force and the time for which it is applied that is important, which is where we get change in momentum equals force times change in time. Impulse is measured in newtons per second. In our example, Brendan hits a tennis ball with his tennis racket. Brendan exerts a large amount of force onto the tennis ball over a short period of time. We can calculate the impulse by measuring his force when striking the ball and the amount of time it takes for the ball to hit the wall. Elastic collisions. Elastic collisions are defined as collisions where momentum is conserved and so is kinetic energy, meaning neither the kinetic energy nor the momentum is lost. When these tennis balls collide, they deform but quickly bounce back into their former shape and transfer almost all their kinetic energies into their respective balls. That is why the balls bounce back at pretty much the same speed. They originally had the same kinetic energy and momentum, and that energy is transferred into each other, so afterwards they have the same kinetic energy and momentum. The formula we use for this collision can be written as
m1v plus m2v equals m1v plus m2v. Inelastic collisions. An inelastic collision occurs when two objects collide and do not bounce away from each other. In an inelastic collision, momentum is conserved, but kinetic energy is not. Kinetic energy may be converted into sound heat and/or deformation of the objects. Since both train pictures have the same mass and about the same velocity, they have the same momentum moving in opposite directions. The reason they stop dead after colliding is because momentum is conserved, and since both have equal momentums in opposite directions, the resulting momentum is zero. The formula we can use to represent this is m1v1 plus m2v2 equals m1 plus m2 times v. You can see that since the velocities are in opposite directions, when added together, they cancel each other out.